Hey, hello. Welcome back to the channel. In this video, we're going to see about the major differences between mass and weight. So let's begin. So let us start with the first one, the first point. Quantity of matter in a body is called as mass, and the gravitational force acting on a body is called as weight. So generally, quantity of matter, so we know that matter is something which occupies space and have some mass in it. Okay, so here matter is something related with the number of atoms in that substance. Okay, so that's why at second point, mass of a body can never be zero. Okay, so quantity of matter in a body is nothing but you can relate it with the number of atoms present in a particular body. And at the same time, when it comes to weight, the gravitational force acting on a body, so we know that on earth we have gravity, which is the pull from the earth, which is making all of us to be on the ground. Okay, so the gravitational force which is acting on each and every body is making us to be on the ground, so that such that we are not flying, right? So the gravitational force which is acting on that, on a particular body, okay, that force is called as weight. Okay, so here the major difference is mass is something different and weight is the gravitational force. Okay, and then the second point, mass of a body can never be zero. So if you take a matter, of course it is composed of atoms, so it cannot be zero, it can never be zero. Okay, and weight of a body can be zero if the value of g is zero. Now what is this g? Okay, so this g is nothing but acceleration due to gravity. Okay, acceleration due to gravity. Okay, so for clear understanding, acceleration is nothing but the rate of change of velocity with respect to time. Okay, so acceleration is nothing but the rate of change of velocity. That means how fast velocity changes with time. Now here what I have given, acceleration due to gravity. So because of gravitational force, if an object is changing its velocity with respect to time, that is called as acceleration due to gravity. Okay, so now this acceleration due to gravity has got a constant value. G is equal to 9.8 meter per second square. Okay, so if this value becomes zero, G is equal to zero, if this is becoming zero, then the weight of the body also can be zero. So it's in a very simplified way. If in a place, okay, if there is no gravity, then the weight also will be zero. Okay, and the third one, mass can be measured using a physical balance, and weight can be measured using a spring balance. Okay, and the fourth one is mass remains constant. So if you take any object, okay, if you take some object, okay, now if for example, okay, this is for our understanding, you just imagine that there are around only 4 atoms in this object. Okay, even though if you're taking this object from one place to another place, or even like even though if you're taking to space, okay, or to some other planet, the number of atoms in this particular object will never change, that will be the same. Okay, so that's why mass remains constant, but weight changes with change in the acceleration due to gravity. So already I told, if there is a change in the acceleration due to gravity, if the value of g is getting decreased or if it is getting zero, there will be change in the weight. And we know that as we are going higher and higher from the earth, okay, the value of g will be decreasing. That means the gravity will be decreasing. So as the gravity is getting decreased, your weight also will be decreasing. Okay, and on the earth, let us understand how the value of g will be on the earth. So near the poles, okay, near the north pole and the south pole, so near pole, the value of g, okay, the value of g is maximum. Okay, the value of g is maximum near the poles. So if the value of G is maximum, the weight also will be maximum. And if you see near the equator, the value of G is minimum. Weight will be differing. That also will be minimum. Okay, so weight is completely depending on the gravitational force acting on a particular object. Mass is something related to the number of atoms. And the last point, the SI unit of mass is kilogram. Okay, and the SI unit of weight is Newton. So here comes the big deal. So we need to understand clearly. Uh, for mass, we are telling it as kilogram, and for weight, it is Newton. Why it is Newton? Because it is force. We know that the SI unit of force is Newton, right? So now, are we measuring mass of an object or weight of an object on Earth? So generally we use weighing machines and we'll be calculating our weight. So actually it is the weight of the object or weight of yourself, whatever you are measuring on the Earth. It is not the mass of the object or mass of yourself or mass of a person. It is actually the weight of the object, whatever you are measuring using a weighing machine. But sir, like why we are using the term or the unit kilograms? We tell 75 kilograms. We don't tell 75 Newton, right? So to understand this, what happened was the usage of the unit was changed. Okay, so we have got another unit for weight, okay, which is called as the gravitational unit. Okay, so it is kgf, that is kilogram force. So 1 kilogram force is defined as the gravitational force with which Earth attracts a body of mass 1 kilogram towards its center. Okay, so this 1 kgf, that is kilogram force, is actually the unit which was used, but people have started to use this kilogram force as kilogram itself. Okay, so only the usage of the term has been changed, but it is actually kilogram force only. Okay, that is why whenever we are using a weighing machine and when we are weighing the weight, when we are measuring the weight, we are mentioning it as 60 kilograms or 75 kilograms or 20 kilograms, but actually it should be kilogram force, which is the gravitational, which is the of weight. Okay, understanding you need to have. So we are measuring the weight of an object on the Earth. Okay, and if you want to find out the mass of an object, like if you are having the value of weight, you need to find out the mass of an object. So we know that weight is equal to mass into acceleration gravity. This is the formula. Okay, now if you know the value of weight and if you want to find value of mass, so what you can do, mass is equal to weight divided by acceleration due to gravity, such that you will get the value of mass. So when you're writing the mass, in that case also you will be mentioning kilograms only. But scientifically, when you are writing the value of weight, you are not supposed to mention it as kilograms. Only in the usage, like orally, people have started to use the term. So orally you can tell as kilogram. Okay, but when you are writing it, you are not supposed to write it as kilogram. It is actually Newton, or it is, you can write it as kilogram force. Okay, and another thing is 1 kilogram force is equal to 9.8 Newton. Okay, so this is the value of 1 kilogram force. So accordingly, depending on the mass, the kilogram force also will be changing. And if you want to convert to Newton, you will be able to convert, because 1 kilogram force, you know the value in Newton. Okay, so like if it is 20 or 30, you can easily calculate. Okay, fine. So at last, thank you all. Happy learning.